Hello, everyone. My name is Alexander. I'm glad to be here. Good morning. I'm engineer lead at AI team or at Wargaming Studio in Kiev. And today I want to speak about static pre-generated game AI content for online vehicle shooter that helps to create better AI and reduce some server performance issue. To give you a little bit of background, we create a game AI for World of Tanks PC, and our bots use it for standard PvP game mode, especially for Battle for Beginners, and for different PvE game modes, such as Bootcamp for Beginners, Halloween, Steel Hunter, and other. So, let's go to our topic. First of all, what is Game AI? Game AI it's a system that try to be like a human and try to pretend a human or character. And depending on what game type, genre, and game goals, it can be different techniques and approaches to create such game AI. And today we will speak about game AI for competitive online shooters such as Battlefield, Call of Duty, and World of Tanks, and how we can create such AI and boost their performance. So, first of all, the main feature of such AI is that it's server-side AI. So, for the game server, bots is just another player. So they control vehicle or unit as the player, push the button, virtual button. They act as a player. They have the same rules, the same abilities, and so on, and they doesn't cheat. So this approach leads us to situation where server resources use it not only for physics, battle arenas, networking issue, and server game logic, but also for controlling and making decisions for AI agents. And the more such agents on the battle arena, the more resources needed us from server, and the more calculation we can done for such agents, the more smarter they will be. So it's always a trade-off between smart game AI and how many calculation we can do per server frame. So if we can do something offline, prepare some data for bots offline, it's better to do this offline because it's really help us with heavy server performance issue. And also we have another issue. Player have some experience about battles. They play a lot of battles. They study arena. They study best technique, best strategy, best approach to how to play in specific vehicles in specific situation. Bots always the same. They didn't have such combat experience. So we need create so-called cumulative combat experience for them. Prepare some answers on question how I should to play here, what is the best approach for my specific vehicle, or so on. Also, bots didn't see a beautiful visual map, so we need to make some sense data that allows them understand geometry and different stuff in the map. So for that reason, we create some different static layers. And today I want to speak about two common static layers that maybe all know, and three static layers that we create especially for World of Tanks. And in the end, I will show several examples how we combine these layers for resolve some AI issue and help make some decision for this AI. So let's start from the navigation mesh. I believe we all know about this layer. The main purpose for this layer is to allow bots to move on the map. So this technique was firstly created for robots in real life that they can move through physical world. But in game development, we understand this is a good approach and implement it. The base idea is that we divide entire map on square rectangles and in these rectangles, we know about our self ground type, cost of pass from this ground type, and we know all about our neighbors. So we can we know connection about neighbors, and we can build pass from one point on the map to another just using this connection for neighbors. For that purpose, we use some different pathfinding algorithms such as a star, wave, or other. Also, it's a good way to prepare different now mesh layers for different agent size, agent types, and even goals for engine. Also, in World of Tanks, for example, some data are static, so we pre-generate this data before game start, basic on level geometry. And in the battle, we add some dynamic part. For example, if some building will destroy it, so we can and block some part of map, we add this on our mesh layer and mark that for bots that you cannot go there. Also, we can add some transition points in this no mesh. So, for example, like teleports, lift, and so on. And for different type of AI engine, we decode the information. It's good or bad ground time for them for moving there. Uh, Sometimes we have funny bug with now mesh, like in the picture on here Counter Strike old version, when bots try to move from fence. Because I believe is here we have a now mesh under the fence, and bots don't understand that they're fence, and they see that they're now mesh, so they can go through this now mesh. And when some bots stuck in the door walls, this too related to now mesh issues. A lot of common known engines has some tools for now mesh there. So, for example, for Unreal Engine and Big World Engine that's used for World of Tanks, base of now mesh is Raycase Navigation Library, and then both engines add some custom libraries and custom development stuff to make it more suit for this game engine. Next step, cover system. Cover system is a system that allows bots not go forward to enemy and hit it, but to find cover and make more safe way to participate in battle. For cover system can be divided in several parts. First part is the most heaviest part. It's generate base cover before battle start. How you can see in the bottom screen, it's a screenshot from Wargaming, and it's a screenshot from generated cover points for tanks. So this is a static part where cover generated across building, big rocks, big trees, and so on. Also, we have dynamic parts of the cover. This is when some buildings destroy or some vehicles die and became a small cover. Also, cover can be different. For example, some cover can be movable. For example, trains that go and in each part of time it's cover for some of part of the space. Also, sometimes cover can be non-protective, but just visual. For example, some floor covers when it hides you from enemy, but if you get shot through this cover, you get damage. Also, when you generate cover, you need to add some custom data to this cover because, first of all, you need a cover point where it's situated on the world map. Second, you need a cover arc engine where you can see from what direction and what degrees you are protected are. Also, for example, for World of Tanks, we have some called shooting point. This is a point when you can need to go for shoot enemies on such some direction. This is very important because you, if you generate the shooting point, you do not need to search the shooting point while you in battle. So you really cut some performance issue. Generation of cover is really heavy work, so it's need to more optimization. And the main problem in real battles that you need to search cover, and you have a lot of cover points, and filtering this cover to find the best cover for special for the agent. So sometimes, maybe even often, we put some information for what type of AI engine, vehicles, and situation this cover is better. There are two main approach to generate cover. First approach is based on no mesh H. So we go to the place where no mesh is ended, and try to understand what object behind this ending. And if object is big, if object can be cover, we mark them as a cover and put these points on the edge of no mesh. This is a good approach. This approach, in general, fast, but it approach has some problems with accuracy, especially if object is complicated form. But better use this approach for different for generated cover based on difference of height of ground. Second approach is 3D scanning of object. So we take object like in right picture and select a lot of points and make raycast for this object to understand from what angles and direction this object protect us. How good he protect, what his height, weight, and other parameters. This very heavy approach. So this done only offline and took really long time for one map for World of Tanks. So this is better for static cover. When you need a dynamic cover, for example, some part of building destroyed or some plants down to the map, you can use null-mesh H walking approach to generate this cover from null-mesh during the battle. And combine of these two approach we use in World of Tanks for dynamic and static cover generation. Then let's go to the strategic zones. Strategic zones. This is a zone where we we divide a map for bots for different zone, and we add some information to the zone for what this zone is better suited, for whom, for what type of AI engine, and what type of game situation this zone is better. Often, this zone also have transition links from one zone to another zone for bots to better understand how they should move from one zone to another zone. Also, the main commander in World of Tanks control not where bot should to go, but control gives suggestion you should to push the zone to take it zone and control the zone, for example. Now, the most part of our zones created by game designer in manual approach. Also, we use heat maps for understanding where more player play and what situation in that in that specific area are was in, from player to give this information to the bot. For example, here we can see in the right side one example of real zones and some custom information. What we put in this zone? For example, we have red zone and we have colorful zone, for example. And in this red zone, we have information where's the best cover that protect from opposite zone, from zone 1 to zone 3. Where's the best snipe point to detect enemies and destroy enemies in opposite zone, and where's that place where you should push from one zone to another to capture that zone. Also, you know where's the potential the best place for enemy sniper, so you can control this or make some hide some glass cannon tanks here, because sniper can hit here. And all this information also zones has information about transition. For example, we store information how what is the best way move from zone 2, for example, for zone 0. It's a zone 2, zone 1, zone 0, or maybe zone 2, zone 4, zone 3, zone 0, with precisely points where this transition on the map goes. Later I show example how it used in real battle. Next one, this visibility grid. This is a layer that need for answer the question: how good how good this position for hit enemies in specific area, or how good this position to hide from enemies in specific area. What we done? We divided. If you want to shoot some enemy and check can you shoot him or not, you need to make a ray trace to that specific position. Ray trace is very costly operation for server performance. So what we done? We divide map on rectangles, select 20 random points on this rectangle, and make traces for all other rectangle on the map and color that rectangle. If you see white color, that means that it's easy to hit all 20 ray trace collide has no collision with any object, static object. So this can be easy to shoot. If you see dark areas, then this means that you didn't shoot any of these 20 points, and you can be saved here. So in real battle, we just check how good this position, for example, red square, where the bot for opposite position, for example, some position here on the road left from that spot. And we can see, yeah, here we can easily shoot any enemies, so we can hold this position and wait for enemies to came. If we want to hide, so we understand that if enemy go from the left, this is a bad position for us, and we can be hidden here. So better find some position up on hills. Almost in the and this data store in very convenient container that's loaded in game. So it's really cheap to get data from one point to another without doing ray trace. The next layer it has the same logic. In World of Tanks, we have detection mechanic. So what does it mean? To see enemy before you see enemy, you should detect them. Detection work from distance and your equipment. For example, some special radio, some other stuff that help you detect enemies. And we have different roles for our bots. Some bots are tanks that just push and fight, but some tanks are scouts. So the main goal for them is to run maximum to the enemy position, hide there, and try to detect as many enemies as he can. So we again put a lot of triangles on the map and make calculation how good these rectangles can be used for looking for other enemies or hide it from other enemies. If you see light green, that means from this position, red square, you could see you can easily detect any enemies who near and any enemies who are in the left part of the map, bottom left part of the map. But you have problem in the darkest area. So in general, this is not a bad place to scout. And for reach this region safely, you can see that you have almost dark green areas. You can build road here in the right part for reach this point for scouting. Okay. And of course, this is done offline, and we load this layer to the game and use it very easily because it's stored in data containers that have cheap access time for the access this information. And let's go to the examples. Uh, First example, it's about bot. We have an AI bot in the bottom of our picture. This bot need to go to the endpoint to flanking these three red enemies. What we done? Firstly, we use our cover system to find some cover in that endpoint. After we find this cover, we use null mesh to build paths to this cover. We get different passes. For example, this orange and this green pass. Then we use visibility grid against our enemies and ask how all points on this path, for example, divided in 1 second or 2 seconds, are good and protected from these enemies. And we place uh, visibility grid point on each enemies and see how this square here are they white or not. If they white, this means that we can potentially get damage. We calculate on each point how many potential damage we can get, and understand that this pass can uh, can we can lose 70% of our HP in this pass. This is the best bet variant because we will be weak player after losing so many HP. So we decided to check this pass. We see that Black Rock. This is a cover, so we protect it from this enemy, and we can go through this pass easily and occupy this point and fight them from this point. The next example, this is example based on Scout. Here we see Black Rock, this also cover, and we see green flora, bushes, trees, whatever. Our goal for this AI bot, this Scout, is to reach endpoint and try to detect as many enemies as he can, but this bot need to be hidden from these enemies. So what we done? In general, we use cover system, find some cover point here for be protected. Okay, we find this point. Then we use now mesh to build passes to these points. We have two passes again, orange and blue. Then here we see some flora. So theoretically, we hidden from these enemies because flora is hide us. But we have some places here and where we can be detected. So we use visibility gate and stealth gate to check about these enemies, how good they can hit us here if they detect us here, and how good they can detect us here if they want to detect. And we see that enemy one, it's okay. We can move on orange pass and we will be not detected. But for enemy two, who may be scout two, we will be detected because he has better equipment for detection. So in this case, it's better to again use more long way, but more safe way to build pass and stay hidden and occupy this point for in future detect these enemies. And the last one story, what I want to explain, this is a story about strategic zones. So here we see that our entire battlefield divided on 9 zones. The green dots, this our allies, and the red dots, this our enemies. We are blue dots in zone 3. Mm, and our goal find yellow targets in zone 9 and destroy it. This target, this is alterally, and we want to destroy it. So first of all, we use this strategic data to understand where's the best place for that for our target, zone 7 or zone 9. We understand that 90% that's the best place for enemy artillery is that zone 9. Okay, and next we want to build pass. In zones data, we have some pre-calculated pass and cost of pass, because you can have short pass, but complicated pass with different climbs, hills, and so on, and different and really different ground types. So we have a score based on this pre-calculated path. We know transition point where we need to go, where we better place to go from one zone to another zone. Okay, there we have 4 passes: orange, yellow, violet, and blue. Then we need to detect to choose what pass are the safest pass, because as we hunter, we have less HP but more damage. So if some enemy hit us, we can fail our mission. And in general, better to be hidden from enemies during this travel. So then after we select these passes, we add some dynamic information about threat level in each zone. So we can see the shortest way is zone 6, but here more enemies than our allies, and we understand that our allies retreat now. So if we go here, we will be 100% hidden and fail our mission. Zone 5, it's in general seems be good. We have some score 7 and 8 about this pass because we have equal situation here for enemies, for allies. They fight, so maybe you will success to go through this pass. But if we want to 100% be sure that we reach target and surprise its target, better to use more safe road. Here we see that here equal situation 2, but from zone 1 to zone 4, one our allies moving. So here will be our, for us, there will be better situation. Uh, it, and we believe that our enemy will be busy, so we can use this long road with these transitions areas to go to from zone 3 to zone 2, 1, 4, 7, 8, and 9. And this will be better for us in percentage perspective to reach our target and complete our mission. In general, that's all story. We have more different layers and different situation how we use these layers. For example, we have hate maps, we have different maps where best to hide from different enemies and so on. But it's a really big topic, so and interesting. So if you have any question, I would like to answer this question and be happy. And thank you for your time. That's all.
Thank you very much, Alexander. Very interesting presentation. What engine are you using to develop?
We use custom engine. It's called Big World, and it's written on C++. But we also use Python as a tool for scripting game logic.
Do you use systems like ECS to optimize?
Sometimes yes. It's hard to answer to this question because we have a lot different approach in our game engines and a lot different custom way to optimize what we need, because we try to make engine for specifically one game for our game.
This is too technical, but for visibility grid, would it be possible to use heat map combined with float fill algorithm to find if AI can shoot?
Maybe yes, but sometimes heat map not only answers to question where battles or events happen, and it's not 100% cover our needs. But in general, this is second version of visibility read. First, we make it radial. It was sometimes better, but unfortunately not cover all variants.
Thank you, Alexander. I see that there's more questions coming in. They're very technical. But one last one. There's Phil is asking, can you make that presentation slide available?
Yeah, of course, no problem.
Yeah, we will have the recording, by the way.
Yeah, and I have downloaded PDF. If you can share PDF with my presentation, I will be good with it.
Thank you, Alexander. If you send it to us, Phil, you can reach out to us and we can send you the PDF.
Great. And you can answer me any question for me. I will be glad to answer you in after presentation.
Yes. Thank you very much, Alexander. Yes. If you can stay here and answer some of the questions.
Of course. No problem.
Thank you.
Thank you so much.